email, so we don't know how to answer these. But if you want to drop your email in there, that'd be great, because then we can answer your question. That was a small oversight on our part. So, whoops. Announcements, got a couple things here. Volunteer for ISTS. Who here has never heard of ISTS? Okay. So I think you all have heard of ISTS based on the people who raised their hands. It's our competition we run. It's in February, and we have tons to do for it. So we're just like lining everything up now. We've already had a bunch of meetings on it and everything. So it's going to be a great time. If you want to sign up for white team, that means you cannot blue team. So just don't sign up for white team and be like, oh, I'm helping out, and then decide you want to blue team, because we're not going to let you blue team because now you know all the secrets from white team. So it's kind of bad. So yeah, if you want to help out, we'd love that. We need all the help we can get. We're going to keep you posted on when blue team gets released. We haven't set up the signups for that yet, but that'll come later in the year. So just kind of keep following up for that. But you're welcome to help out if you would like. Next up, we mentioned last week we have some junior positions. One of the positions we forgot on here is junior infrastructure lead. So if you want to help out with like setting up ESXi, setting up all kinds of different services, like maybe GitLab, or I don't know what else they have, NSX, all kinds of fun stuff. You get to help out with Brandon. That's pretty cool. So if you want to do junior infrastructure, that's on here as well. There's also junior tech lead who helps out with the weekly demos, and then there's going to be junior competition architect, and yeah, sorry about that. And they're going to help run RITSEC in the spring as well. So juniors on there, make sure you fill them out. We're going to be pulling things here in the next week or so. So make sure you get on there, a position that you really are interested in and want to do. We have CCDC Tryouts. That's actually tonight. We talked about this last week. It's a great way just to learn. If you're like, I've never blue teamed before, and you hear us talking about ISTS and IRSEC, and you're like, how do I learn how to do this stuff? This is a great way to learn how to do this stuff. We put you through some different little challenges and stuff, and we're going to sit there and work with you, and we're going to help you learn to set this stuff up, figure it out, kind of get a level head on your shoulders. And it goes great with today's talk, which is Services 101. So we do all kinds of different services. And in addition, we do some just like different types of security. We have business writing. If you're like, hey, I want to be less technical, you want to write up injects and kind of help out with that. We have less technical business writing. So any skill set can kind of be applied if you just have the attitude to be willing and learning. So we'd like to see you tonight. In addition, we have a lot of new people this year. I'm the assistant coach at the program.
Joe. Oh, come on. Oh, man. There's a stream. Hi. I forgot that we stream this and that you have to talk into a microphone. I just wanted to add on. I'm the assistant coach. I'm Joe Graham. Even if you don't have a skill set, like we have a bunch of skills up here, and there are a lot of bright, new, young faces in the room and on the interwebs this year. Even if you have no skill set, we've been doing this for like over a decade, I think, and we can teach you. So like if you're new, you don't know any of the things that were on screen a second ago, that's fine. We will give you that skill. We just want you to learn, and yeah.
And if you like mail, you get to come hang out with me, so that's always a plus.
It's a spoiler.
Because everyone loves mail. All right, so news. Why is that on here? We do news the second half. All right, there's no news. Come to the research side for the news. All right, week 4, introduction to services. We're going to talk about some basic services and kind of how you set them up, how you work with them, and on Linux and Windows. So, services. What are services? In Linux, you often hear the word daemon. They're kind of something that's just sitting there in the background. They're not on your user prompt. They're not on where you didn't run this process. They're things that the system itself is running. So for example, like SSH, you wouldn't want SSH running only when you have a shell open, because what if you log out and turn all your things off, then SSH is going to stop. No, you need it running as a service. And that's kind of where process or services and daemons come in, and how that's kind of handled on Linux. We'll get into that a little bit more. And then on Windows, they're fairly similar, but there's a few differences. Kind of as always, there's just some things you want to be aware of going into both of them. So how Linux does the daemon, and you can see Matt Damon there. So services are controlled by what's called the init process. So that is the very first process that starts. The kernel's going through, and it's like, all right, we're going to go, and then it starts init, and then init just kind of calls everything. So if you did PS on Linux, PS-EF, everything, you would see all the parent processes all the way back up to 1, and then 1 is started by 0, which is the kernel, but everything else is pointing to 1, and that's in it. So nowadays, we use this thing called systemd instead of sysv in it. They're just two older systems for managing sys5 in it. What?
I'd like to interject. There are still a lot of places that systemd is not used.
There is. And most people don't use those places. But no, yeah, so
Ever heard of this little thing called Juniper?
no.
Or PSense?
No. Not in production. So anyway, yeah, so there's kind of the older one is sysv in it, and then there's new one, systemd, which has taken over a lot of the different operating systems, much to the chagrin of the Linux community, I would like to say, and Scott. So if you want to do system services, you just call, that's really hard to see, systemctl, and then like the verb, so there's different actions you can call, and then the service. So I might be systemctl start SSH, systemctl stop SSH. And then that's also mapped kind of to service. You can do service SSH stop and start, but that's just kind of backward compatibility. So it should be if you're on a system that's using systemd. So that's kind of your basic commands. You can check your status, see if it's running. Enabling and disabling, which says, is it going to run on boot? When I start up my computer, it's going to automatically start, and then just starting and stopping. It's pretty simple. So there's a lot of tutorials out there, and you kind of find a lot of information about systemd, but it's a great place to start when you're like, what is this thing that's running on my system? Do status, and it'll kind of tell you what it is and kind of get going from there. On Windows, it's a little bit different. So Windows has the service control manager, and everything kind of points back to that. It's sort of like systemd for Windows, I guess. But so the thing with this is everything is pretty much GUI based. And Brandon, do you ever use this, the SC command? You do? All right, so Brandon uses that. I've never used that in my life. I've only ever used services, which we'll talk about here, I think, on the next slide. But you can interact with these from the command line. You can also go to like Task Explorer, Process Explorer, Task Manager, and list all your services, and you can enable them and disable them through there. So yeah, it's kind of a similar concept, though. You have this one process or manager that's kind of running everything else. So Linux, you picked Linux because you want to have control over your system. Okay? This means you need to know where the configuration files are. Most of the time, it's in etc service for like older things. If you're on Red Hat, they like to change that up a little bit. If you use more modern technologies, are going into like /var opt and that kind of stuff, /opt for I don't know, a lot of different things are moving around. But most of the time, like etc service, like so etc postfix or etc sshd or etc dovecot, whatever your service is, and then you can find the config files somewhere in there, usually .conf or .cs, sometimes like that. And then this is going to just say D denotes a daemon. Sometimes you'll see like whatever .d, probably a daemon runner of that service. So that's just, as we said, kind of always running in the background, always listening. So just kind of something to be aware of from there. Windows config file, a lot of the stuff is in the registry and services.msc. So this is like the best thing to work, in my opinion. I don't really do too much Windows, but it's, you have like the nice interface. You can kind of click around, see all your options. So who's taken like net services or sysadmin 1? Yeah, you kind of get familiar with some of this stuff. You kind of learn how to work with services a lot. It's actually a very useful class. But you're kind of going to dig into all this and be like, how do you start managing these services? How you start stopping and installing and all that kind of different stuff. So, core services. Hopefully, most of you have heard of at least one of these. And then the other half should have heard of all of them. But we have things like DNS, domain name service, kind of resolves names to IP addresses. So google.com to 8.8.8.8 or whatever IP address they're using at the time. Secure shell, we've all used that. I think on Linux 101, maybe not. We will be using it today, right, Scott? Secure shell, SSH? Yeah. So pay attention, because this is going to help you out if you're doing the demo. FTP, file transfer. SMTP, that's mail. RDP is basically for Windows. You can just get a connection on another system and play around with that. You get a GUI projected to your computer. DHCP, that's how we get IP addresses. MySQL databases, there's other databases, NoSQL. Apache and Nginx is web. SMB, that's file sharing, kind of like FTP, but more of a Linux or a Windows kind of thing. And then there's Telnet. We don't use Telnet, but it's like the only service you're really going to learn in class because it's like what all the demos are used with. And it's easy because you can see all the traffic, which is exactly why we don't use it outside of a learning. The hierarchy is basically, it starts at what we call the root domain. So that is, if you think like you'd have google.com and then picture a little invisible dot there. That's the root. And then as you go through, you say, okay, well, do I know where Google is? No, because I'm querying Google. So then I'm going to say, okay, let's go to .com. Do I know where .com is? It's like, you probably know where .com is. And if you don't know where .com is, then you're going to go to the root. And the root knows where all the what we call top-level domains, so that's this part, and it knows where all they are. So there's like com, .edu, .net, .biz. There's a bunch of weird ones now, .xyz. So someone has to be in charge of running these TLDs, top-level domains, and then I think it's ICANN who's in charge of running the .domain, which knows where all of the TLDs are. And then it kind of, it's a tree. I don't know, it's hard to visualize, but it's a tree. So you go all the way up. So if you don't know where this is, like say www.google, you don't know where that's at, so you go to Google. But if you don't know where Google is, you go to com. If you don't know where com is, you go to the root. And then the root will say, well, com's here, so then you go back to com. Com will say, okay, Google's here, so you go back to Google, and then Google says, okay, www is here, and then you get the IP address. It's kind of a little bit more than you need to know for now, but just that's kind of how DNS works. There's recursive and iterative, so there's two different ways. If you're in CS 101, you do like the tree traversals and all that. So you can traverse the tree iteratively, or you can navigate the tree recursively. So picture the same way with DNS. There's two different kind of ways to get around it. There's different types of records. So when you go to query these domains, different types of records you've been querying from. So CNAME, canonical name, canonical. So basically, what? Canonical. Canonical names map a name to another name. So I could be like, well, I want to map ritsec.club to google.com. So then whenever you query ritsec.com, or ritsec.club, it'll return ritsec.com, or google.com, and then you'll navigate there. So it's a mapping of a name to another name. You have A records or quad A's, which is IPv6, I believe, and that'll map a name to an IP address. So if you go to ritsec.club, it'll go to 129.21. wherever it's at. And then there's MX, which is mail. So that basically says, for google.com, where do I send all your mail to? So it's going to return with a record. And then you have the start of authority, and that is, who can tell me all this information? Who's allowed to be like, yes, this is where all your domains are? Because as you can imagine, it'd be a bad idea if I was in charge of all Google's domains, then I could tell everyone where Google was, and then I would be sending traffic wherever I wanted it, and not necessarily to the real Google. So that's where the start of authority exists. There's a couple more in there. There's like text records and all kinds of fun stuff. So if you want to look them up, you definitely can. This is all very well documented stuff. Now we have the Better Telnet. This is SSH allows us to get, we all have played with the Linux prompts if you were here for Linux 101. So it allows you to get a prompt from a remote computer. So we can say, okay, I'm gonna sit here on my laptop, and I want to get into this server. That server doesn't need to have a GUI running anywhere. It doesn't need to have like this nice thing where I have a mouse and a keyboard. I don't have to physically walk over and get on that computer. I can SSH in, and then I just get this shell, and from that shell, I can kind of control everything that I need. That's SSH. SSH stands for secure shell, because SSH wraps it and encrypts it as you go through, and then all your traffic is hidden, so they can't see the passwords and everything that you're typing in. Your thing. A couple settings for this. Permit root login. You don't really want to allow root login. There's no reason you should be logging in as root. Best practice. You should log in as whatever user you are, and then use sudo to kind of get root privs as you need them. So by default, it is without password, and we'll get to that in a second, or just turn it off. So it's kind of one of those. X11 forwarding. So let's say you really do need that GUI interface on your server that's sitting somewhere up in the cloud, and I want to open my calculator and type in things, but I want to use the calculator is actually running on the server. That's called X11 forwarding. It basically sends the graphical data to your computer while all the computational data is still on the server. So SSH supports that. It basically took X11, which was a not so good protocol. Everything was in plain text, wraps it over SSH, encrypts it, allows everything to be a lot more secure and a lot more hidden. The banner, that's a greeting message. That just shows whenever you go to SSH into whatever host, it'll just prompt a little thing. Usually it's like, I think on RIT servers, it's like, oh yeah, don't touch, like don't do anything illegal on here. It might be being monitored. Just all depends on what the system is. So you can change that with the banner setting. Authorized keys file, that's going to be which keys you're allowed to connect with and where that's stored. Usually it's going to be in your home directory .ssh/authorized_keys. And that kind of goes in with public key authentication and then this without password. Who here is not familiar with public key encryption and SSH keys? Anyone? All right, so we all kind of have at least some understanding what that is then. So that allows you just to sign in without a password. You're signing in with a key instead. And that's with the without password. So you just say, OK, you can only log in as root if you have the key. You can't even type in root password, even if it is correct. DHCP. Dynamic host configuration protocol. That basically is how you get your IP addresses on a network. So if I plug my computer in or I connect to the, I don't know if it works over Wi-Fi. It works over Wi-Fi, right? Yeah, so you get on this network and you don't have an IP address. So there's two things I could do. I could either A, figure out what network I'm on, find the default gateway, find the router, find all this kind of information and my network mask and everything, and then manually type that in. Or I could just say, hey, I'm going to use DHCP. DHCP kind of just sends out a little, we call it the DORA. So it sends out a discover. It sends out a broadcast. It says, hey, I'm here. I need an address. And then we get an offer. The server, the DHCP server that's listening there says, OK, no one's using this, so you can go ahead and use this. So then the client goes ahead and it says, all right, well, I'm going to request to use the one that you just told me I can use. And then the server acknowledges that. And then so now the server marks that IP address as in use until there's a release that comes later. And it also gives all the other information. So it tells you where you're going to send your traffic to, the net mask, so you know what other hosts on the network you can talk to, and that kind of other information. And it sends all that through. And your DNS server can come through there. So that's a great way to do it because it basically means we don't have to manually type in these IP addresses every single network we connect to. So that's the DORA. You'll learn all about her in network services. And net services spends half a semester. Yeah, there you go. The other half is DNS. FTP, okay, so FTP is basically file transfer protocol, listens on port 21. It's not really secure. It's not encrypted by that matter. So again, going back to SSH, SSH kind of started just wrapping all these clear text protocols and encrypting them. So that's what they did with SFTP. It just basically wraps FTP in an SSH encrypted tunnel. That way all your traffic, the files you're downloading and uploading aren't in clear text. So you should be using this, and it's by default on like OpenSSH on Linux servers. So if you want like a file transfer server, you should be using this. Unless you're just running like a public website with just books or whatever, I don't know, whatever you're serving, PDFs. Doesn't really matter if everyone knows because you're hosting it publicly. So common misconfigurations. Anonymous login is enabled. Going back to that, if you're running a public server, anonymous login is great. And by default, your browser will try to log in anonymous. So if you navigate to an FTP site, it'll start listing all the files that are in this FTP server. And that's anonymous login because you have to log in. And I think you just log in with either anonymous or anon, and then just like whatever password, it just lets you in. So that's what that is. But it's bad if you actually want to secure what you're trying to protect the download of, right? So if you let anonymous log in with all your top secret files about, I don't know, your grades or whatever, then it's a bad idea to kind of have that just sitting up there on the internet with anonymous login. Such as kind of a misconfiguration. And most FTP servers, I think, are now turning it off, but there was probably a time where they were just letting it on because who cared about security back in the 80s. CH-own on upload. So whenever you upload a file, you're the owner of this, and then you're the only person that could download this unless you actually modify the settings. File permissions are really hard on FTP. Every time I've ever tried to run an FTP server, just getting like who can download what, how they can download, it's just a pain. Just use SFTP. It's going to make your life a lot easier, and it's more secure. So that's kind of that. File permissions on upload, you can change them so you can be like, okay, this is an executable file, that kind of stuff. And that the problem with, like, who can see a problem with uploading a file and making it executable onto a remote server? Anyone see a problem with that? Just a little bit? No? So that's like common misconfiguration. So he can say like why this is bad. Like obviously you don't want to be able to make executable files on this remote server. If you kind of trigger some way for it to be run, then you have a vulnerability. And that's kind of why these are misconfigurations as well. OK, I didn't make these slides, but my name's on there, so that's cool. Simple mail transfer protocol, mail, SMTP. Port 25, basically, mail servers are a little more complex. I gave a talk on it last year. If anyone really wants to learn in depth about how mail works, talk to me. It's used for sending email. All right, so open mail relays, this is like a big vulnerability with mail servers. Basically, I don't check who is sending. So if you come to me as a mail server, and you come and you say, hey, I'm Joe Graham from Google.com, and I want to send an email to Scott Brink at RIT. Then if I'm an open relay, I'm going to be like, cool. Or no, sorry, that's not true. That's checking the sender address. An open relay is going to say, Joe would say, I'm a Joe Graham at Google, and I'm going to send this to Scott Brink at Google, but I'm not Google. So I'll say, it'll come to me, and I'll be like, well, this says it's for Google. I'm not Google, so I'm just going to pass it on to Google. And then Google would get that email from Joe Graham at Google, and they would probably, hopefully, do their own validation. But that's a problem because now Google doesn't know who sent the email. They don't know Joe Graham. They just know that it's coming from me. Does that make sense to anyone? So ideally, I should never be relaying to a domain that is not me unless the user has authenticated or the user has some sort of proof of who they are. And that's kind of how most mail servers are nowadays. It's really hard to actually set these up wrong, but people do. It's also really easy to mess them up. So I don't know. But mail's fun. It kind of gets complicated, but like this itself is really a vulnerability on the mail server. It's bad for like spamming because then you can, spammers will search for these open relays and then just try and spam out all these emails and spoof where they're coming from. But as far as like attacking the mailbox itself, open mail relays are not a vulnerability. The full mailbox attack, on the other hand, is if your mail server is not storing emails somewhere where there's enough file storage or it's not passing them off to a server that can handle the load, then you just send so much mail that it's full, and then your disk is full, and you can't do that. So at CCDC, that's an attack they've used on us before. They just fill you up with emails, and then you're just kind of screwed. So that's kind of the big one. Mail itself is not really vulnerable in too many ways. It's just complex. That's why no one likes it. VNC, X11, and RDP. So they basically manage a remote computer using a desktop environment. SSH gives you a remote shell. These ones give you a remote screen. So it's like you're on the computer, you have your mouse, your keyboard is forwarded. You can do all kinds of fun things through it. VNC can be used without authentication if it's misconfigured. So that's something to be aware of if you ever encounter something like that. RDP can have weak login passwords. So that's like there's no checking whatsoever against that. You can just kind of brute force it. VNC, and then here's the commands to run them. I think these are the Linux commands, if I'm not wrong. That's not a Windows command, right? That's a Linux command, yeah. So these are all commands if you want to interact with this protocol on a different computer. But they just kind of give you the whole desktop environment as opposed to just a shell. Databases, we all have heard of a term, a database. Even like the least technical person I know is like a database, right? They know it stores data. So you can see why you want to secure the thing that's storing all your data. You hear about all these credit card leaks. They're dumping the hashes of all these websites. That's coming from a database. So if the database is misconfigured, you could leak all the information that your website is storing, or maybe someone else's website is storing, depending on who it is. So MySQL, port 3306, and MongoDB. These are two of the most common SQL server, and then MongoDB is a NoSQL server. So SQL is structured query language. It's kind of a uniform language that works across multiple different types of database. So I could go to MySQL, or I could go to MS SQL, or I could go to like SQLite, and I'm using the same query language, but they're different databases. NoSQL, on the other, like MongoDB, is just kind of, it's a unique thing. They're all new. There's no structured query language between them all. It's all just on a per service level. So you kind of have to learn a little bit more with that. And then in addition to that, there's relational and non-relational differences, but that's a little bit outside the scope of this talk. So if you're interested in databases, that's a whole rabbit hole to go down. Poor configuration, so not sanitizing input and SQL injection. You hear about this a lot. So again, we have this structured query language that works on a lot of different types of database. So if I'm in a website and I type in a command, then we could twist that command to modify the actual SQL language that's being called on the back end to potentially get more information, less information, or maybe get into something I shouldn't. And we're going to have a demo of this on the web week. We can learn a little bit about SQL injection and how that works. It's actually pretty interesting. And then in addition, weak, default, no password kind of stuff. MongoDB had a thing for a while where their default configuration, it would listen not only internally, but it would also listen on the external port. So everyone was running this MongoDB. Maybe they're only querying it on the local host, but it was still listening externally. And there was a couple of attacks where people would go through and they just find all these Mongo databases with default configuration externally, try some default passwords, and log right in. So that's kind of an example of why you got to be aware of like what each service has to offer, what each service's weaknesses are, kind of what do you need to configure and what you need to check. And then if you're the attacker, what are the vulnerabilities that you can look for, what you can kind of go through and find this. So just kind of an example of that. Web, we have HTTP and HTTPS. Again, one's just a protocol. The other one's a protocol wrapped in encryption. So we basically made all this stuff. We didn't encrypt any of it. It was all out there in the open. And then we kind of second-handedly went back and said, we should probably start encrypting what we're doing. That's why we have all these things wrapped in SSL and such. So we have an entire week devoted to this. We're going to have like a web demo, week 7, come back in 3 weeks, learn all about it. Scott, this slide says web is week 5, and this says web is week 7.
Interesting. It's week 7.
It's week 7. All right, there you heard it here. So week 7, come back, and you can learn all about web. Common problems with this, again, SQL injection, cross-site scripting. You're not checking the information that the user is giving you. You just like, if I say, hey, type in your password, I'm going to trust that you're going to type in your password and not or 1 equals 1. And that's a SQL injection thing. And then, or I'm not just going to put random escape characters in there and get the website to do what I don't want. You should always check what the user gives you. Never, ever the user gives you. The next thing is permissioning. So maybe my login says that you can't hit this site unless you're logged in as administrator. But what if you directly query the HTML or whatever backend page that the admin page is on? Well, if it's not permissioned right, then it might just give it to you even though you didn't log in. So you can see you need your permissioning set up properly. There's the HT file, the HT access and such if you're working with like Apache. And that kind of says who can access what files, when can they access it. Maybe you could say, well, if your properties weren't right on this, you could access the file system directly. So not even just the website, but you could access the file system of the box that the web server is running on. That's why permissioning is pretty important for web. Uploads, again, you want to check what the user is giving you. If you're just taking these inputs and you're just trusting them, then you could see a problem with that. There's different ways, and if you do like DVWA, that's a pen testing web application, you can like upload an image, but then you say it's an image and you put a PHP shell in there, and then when you go to look at the image through the browser, you're actually just getting a PHP shell. So kind of important to sanitize your inputs. That kind of comes back to this first problem. And if your web server is running as root, which that's also another problem on its own, then you get the system. So kind of a bad idea with this stuff. SMB, this is like FTP for Linux, or for Windows, but more. There's a lot more you can do with this. So SMB client, these are all ways to access these file systems from remote systems. Basically, they are just network shares. So instead of FTP, where it's like you're sharing maybe like smaller things, these are common on Windows to have a whole file being shared or a whole directory being shared. So in the CSEC labs, if you go to one of the systems and you type like / the computer name, / money, you're going to get that share. And that is the entire C drive of that computer on a file share. You can go download whatever you want from the file system. You could look at their all their programs they have installed, their web history, anything you really wanted. It requires authentication by default unless you're using an exploit. There's a lot of exploits against older versions of SMB. So that's kind of when you hear about all these big Windows exploits, MS-08, 67, MS-1710, like these classic remote code execution vulnerabilities, they're almost all in old versions of SMTP, or SMB, sorry. Yeah, so it's file sharing, and you can set these up on Linux too. Samba does. Samba uses the SMB protocol just for Linux. Telnet, again, we kind of talked about this. Think just SSH, but none of the encryption and none of the security settings. So you'll learn about this, and you'll use it in some of your networking classes if you haven't gotten there yet. But you shouldn't be seeing this on a system. If you see this on a system, just turn on SSH. It's actually kind of rare to find this installed by default on most installations. I think they don't let you, like it's not by default on that. So you can do a couple different things. You can send emails with it. You could watch movies. Someone put the Star Wars movie in a Telnet server. So I don't even know if that's still up. That's like, yes, is it? It's still up?
IPv6 is color.
Wow, IPv6 is color. There you heard it here first, folks. So Telnet, yeah, you shouldn't be seeing this, but if you do, just really turn it off. There's no reason to have this running on a system. Detecting services, so this is kind of where we get into scanning. If you don't know what's going on the system, you can use Nmap. Nmap will do a -SV, it's a service scan. It'll try and detect what's running. Is this an SSH server? Is this like a web server? What port's it on? Kind of show everything that's open. How can I help you out? You can do Google dorking. So Google dorking is really interesting. It allows you to kind of search through. It uses like Google has a lot of like hidden sort of features on what you can search and stuff. So it allows you to do different things to tweak kind of the search results. So I think that link is just to let me Google that for you. So if you want to learn about that, that's really interesting.